Hello. Today we're going to make a simulated heat map of earthquakes in a particular region to show how they're distributed. And we're going to make it so it looks like they are based on their size and possibly the impact they might have. This region was from the North Peninsula of the Olympic Peninsula in Washington. We're going to choose a different location for this one. Now, you kind of need to know how many earthquakes your area has, generally speaking, because you want it to actually show something. And if your area has thousands of earthquakes, you want to choose a higher minimum magnitude so you don't have tons of data. Our tool that we're going to use is Desmos, and that limits to about 5,000 quakes, so you want to be careful there. But I'm going to bring ours down to, round it down to 2 as our magnitude. And then we're going to go for the past 20 years or 23 years. And we're going to make a rectangle on the map. And I'm going to zoom in carefully here. All right, so I'm going to choose the broader Seattle area. I'm going to make it generally a square, but you can do the slice, whatever you want. And let me just try to zoom that in a little bit. Yeah, I'm going to want to snip this. So, okay, I'm going to snip this just so I'll have this data for later. Get the coordinates and everything. I'm going to use this region. All right. Okay, so we got date and time, magnitude, 2 minimum, maximum, get as large as we can. The output options, we have to have a CSV file, comma, separated values, and so we can bring it into a spreadsheet. And I think we have our limit. We need to limit the number of events to 5,000, but we're not going to get even near that, I don't think. But let's see. Let's see what we get. All righty. Okay, I'm going to open this in. I'm going to open this in Excel. Although Google Sheets would be just fine for this. I'm going to go to Data, Filter, and I'm going to sort by magnitude. Just see what we get. Largest magnitude of 2. Oh, I went the wrong way, didn't I? Largest to smallest. There we go. We got a 6.8 in there. That's good. 2001. We know when that happened. That was one of our larger quakes in quite a while. Okay, so we're trying to make a kind of a probability map. For 20 years, what's the probability of having any particular quake in an area? And we're going to try to make a little heat map based on that information. So I'm going to snag all 4 of these columns, although we don't need depth really. Although we could do something with it, it would be interesting. But I'm going to snag all 4 because it's easy. I could just delete this one, but I'm just going to copy it. Okay, I'm going to bring it into Desmos. We're going to try to build this in Desmos. And I'm going to paste them right here. And if you notice, there are essentially around a little less than 1,000 rows in here. We could type count, and we could do count x1, and you can see 892. Okay, so here's our map essentially of earthquakes that we have. We don't have anything else here, right? So we have our longitudes, okay, and then we have our latitudes. We have them backwards. So notice how we have longitude. This comes in with the x-axis, so it's shifted 90 degrees. So we need to make different points for ourselves. So we're going to do that. Instead of having the x value first, we're going to have the y value first, comma x. Because this list is the x values in 1 and the y values are in y. So let's zoom out now. And I'm going to turn off these points. So remember, this is going to be magnitude. I'm going to change that to an M just so I'll know. This is depth, so I'm going to put B for depth. Okay. Now here's our points here. Now, if you remember, I had made a square. Let's try to square this thing up. There we go. So this is the square that we have taken this information from. Okay, if you remember, I took a snip of the general area of my region. So I am going to trim it up. And just for our sake, I'm going to use this area. It'd probably be better for me to bring a different map in. And if you've noticed, I have loaded up equidistant maps to try to bring those particular maps into, and here's one of the whole world. Desmos will not import this much data, so it's an equirectangular projection of the world, and this makes these squares perfectly even for the latitude and longitude, and so that enables us to import it into make a flat map out of it. But for now, I am going to save the one that we have. I'm going to crop it, and I'm going to save it. Okay. All right, so let me bring it into Desmos. I'm going to bring the image in. All right, so I need to bring this, essentially center it right into this location. So, we have the data. We could center it precisely. Let me get that off of here. We could, divide somewhere in between 47 and 48. So we could say 47.5 as our center. 47.5 would be our vertical. Whoops. And if we look at that, it's going to be 120, 123, 122, somewhere in there. So I'm going to do 120, negative 122. Boom, here it is. Way too big, isn't it? So I'm just going to go ahead and stretch it. I know that's we should be more accurate with this, but we know that it's going to be right in here somewhere. Okay, so we could figure out the width of this thing. What is the width? Let's go ahead and do the math. Okay, so 48.241. I'm just going to write 48.241. And we'll call that, let's call that longitude, latitude. Latitude 1. And then we're going to call it latitude 2. It's going to be the other version. Let's see, 47.086. 47.086. All right, let's do longitude. Whoops. Lon 1. And we'll do the lower one. 121.410. Oh, and then we'll do 1, 2. 123.168. Okay. So if we want to find the width of this thing, we're going to subtract, we're going to do the absolute value, and we're going to do the so the width is going to be the longitudes one minus 2. Ooh, look at that, starting to fit perfectly. And I'm going to copy that. And then our height is going to be lat 1 minus lat 2. Oh, nice. Look at that fit. It's pretty close. Okay, and then I see I didn't snip it perfectly, but that's all right. Okay, and then we can center it on those two values divided by 2, right? So I'm going to divided by 2. Probably not AB. Take the ABS off in a second. This will be, I better do the, let's see, the width has to be the long, and this will be lat. And lat. Now we got to get the negative over in this side of it, so I'm just going to negate it. Whoops. That's the x values. Where is this guy? We've lost it. Let's see what this value is. Whoa, super small. Oh, I know why. We didn't, we need to add it to the original lawn. Which one is it? Let's see, 40, 121. And we need the original width, the latitude, the height, the lower one. And add that guy. Ooh, there it is. Now it's centered nicely. So we had to do it. We had to add the average in the two to the either side, so it centers it quite nicely. Okay. So now we got our. I might want to change the opacity of that. I'm going to do the opacity as 0.5 because it's a little bit annoying. But at least we see where the quakes are in Seattle. Okay. So the next thing we need to do is we need to make it so these points have some sort of meaning, right? And so one thought, because they're not all the same size. They shouldn't be, right? If you were to look at these, the M1 is the magnitude. So I kind of want to have M1, so I'm going to copy this over. First of all, I'm going to make them yellow. Let's do yellow for now. And I'm going to make it an opacity of 0.5. Now we can change this. I'll show you in a second. And then we're going to duplicate this 3 times. Actually, a whole bunch of times because we have up to a 6 magnitude. Okay, so if it is, basically this is an if statement. If M1 is less than, and let's turn these off for now. If magnitude 1 is less than 2, well, less than 3, there we go. So these are all the magnitude 2 to 3s. I'm going to go ahead and put the bottom on there. So from 2, if M1 is greater than 2 and less than or equal to 3, then show it. Okay? Now the next one we're going to do is we would do 2 or 3 to 4. And then let's make these larger. So this would be a 9. Let's make these a 12. Now I'm going to turn these off right now. Okay, so these are the larger. These are 3 to 4, and then we can go 4 to 5. And I don't think there's going to be any 5 to 6s. 5 to 6. And we do have that 6.8, so I got to get that on there because that was huge. 6 to 7, the 6.8. Okay, so I'm going to turn all of these on. We're going to start with the bigger one, the larger one. So the larger one was down here, and so I'm going to make that one you could feel all the way up at the top area of our zone. So because it can be felt, I'm going to make it very large. So I'm going to make this one a, no, I'm going to even go higher than that. Too big. I know it was felt up in this area, so we're going to call it a 1,000. Nope, that's a 10,000. Okay, and you know, to do this more accurately, we need to know sort of where it was felt. And then let's go down to this one. I don't think there's going to be any points here. And we'll try this one. I'm going to turn this one off. Looks like there's been a couple 4s. Is there any 5s? I don't think so. So I'm going to do the 4s. And we'll make those you could feel. 4 to 5 definitely could have been felt. So we'll give it to we'll give it larger than that. Now I'm just making this up. And let's go. We'll make it even. That's probably good. We'll give it 200, 150. All right, let's go to the next one. And for this one, it's going to be a lot. And instead of this one's down to 150, let's do this one at 15. Now, these are, the magnitudes are 10 times. So, you know, if I go down at that kind of scale, that would be, seems reasonable, right? So the top one is almost 1,500, right? This one actually should be 150, but anyway. I don't think there's anybody there. Okay, and then the smallest one, we will make a size of, I don't know, let's make a size of 5. Now we can have different colors for them too, and that might help, right? We could say this one is a blue, and these are greens. And the next size, we could put orange, and maybe, or yellow, I guess. Next one, we could do orange, and finally you could do red, the outer one. So this is one way we could do a heat map. There are other things you could do, like you could adjust, if you wanted to multiply this by the magnitude itself, so we could do it, multiply it times M1. But if we do that, we're going to have to reduce this value because M1 goes up to, you know, up to 6. So we could reduce this value by 10. And we could do the same thing on all these. Let's see how it works out. And let's see. Nothing there, but that's okay. And we'll have to reduce that one. So adjusting this so it looks interesting, you could have them all the same color. In fact, that might be the way to go. Let's try that just for kicks. So technically this heat map doesn't really give a full gradation, but it does give you an idea of the probability of earthquakes in our area, or in the Seattle area. You can see that certain areas, there's gaps. There's gaps. Why there are gaps, who knows? Or I don't have that information. Anyway, this is a good example of how you can create a heat map. There is one thing you should know. If you do scale this, like if I zoom out, the point sizes are not going to scale properly, right? They're going to scale in a strange way. Okay, that's it. I will put the link to this in the description.